In his book, How We Think, education pioneer John Dewey wrote, "To be playful and serious at the same time is possible, and it defines the ideal mental condition."
Welcome to the A&P Professor, a few minutes to focus on teaching human anatomy and physiology with host Kevin Patton.
This is a special episode featuring classic segments on how teaching is a form of storytelling. This episode is part of a short series of specials in which I've gone back to the secret underground vault containing segments from all the past episodes. Okay, it's not exactly an underground vault. Think more like a wine cellar. But don't think racks of wine bottles. Instead, think one tall glass of iced tea. But it is in my basement, so the underground part is more or less accurate. So, fortified with tea, I've combed through my library of segments to draw together those with a recurring theme that seems to resonate with most of you. And then I've mashed each group together into a single, sometimes rather long episode. So you can hear these classic segments again, back to back. Or perhaps you're hearing one or more of them for the first time. Either way, it's a chance to reflect on ideas that may help a bit as we evolve as A&P teachers and sift through the ideas out there to help us develop our ideas, attitudes, and practices. I often get a lot more out of a book or movie the second or third time through it. So if you recognize a segment you've heard before, I encourage you to keep listening anyway. I'll bet there's a little something, or maybe a lot of little somethings, that you missed the first time through. Or maybe you just forgot about it. I'm finding things that I forgot about too, and I'm the one who said it. So in these classic segments, when I say things like, in the previous episode, that's historical Kevin talking, not present-day Kevin. Now in this episode, episode 48, it's all about storytelling as a teaching process. In the first segment you'll hear, it's originally from episode 12, and that one was called Storytelling is the Heart of A&P, where I kind of lay out my thesis of what I mean by storytelling and how that applies to teaching, particularly teaching A&P. And then the next segment is actually a very recent one from episode 47, and it's about how teachers can flourish in the age of artificial intelligence, where robots may be asked to take on the roles of teachers. But we can meet that challenge by developing uniquely human and humane skills, including storytelling. Now, this one is just a clip from the full segment, so it's going to sound kind of odd at the beginning and end, but you'll get it. And then another segment is from episode 13, and this one is all about how being playful and serious at the same time is the perfect combo for telling stories in A&P. And then I have another segment from episode 8 that walks through a little analogy I do where I talk about how cells hate calcium and they hate sodium, but they love potassium. So it's just applying those storytelling techniques to a tiny little story made up as an analogy to help students understand where to find the various ions in the body and what cells are doing with those ions in a typical resting state. And then I have another segment from episode 15, and this one is one of the most downloaded episodes of all, and that is the one where I go through the analogy that I use when I'm talking about muscles, and I tell the love story involving actin and myosin. And then, there's more, one more segment from episode 37, and that's where I talk about the last best story. And I take that idea of always telling the last best story and I apply it to two emerging ideas right now, or maybe they won't emerge. And that's kind of the point about adult neurogenesis and about autonomic nervous system pathways. Okay, wow, that's a lot. So get your popcorn popped, your iced tea brewed, and let's sit back and listen. It's going to be a long one. Over the decades, I've come to appreciate the idea that good teaching involves storytelling. That teaching is a kind of storytelling. And I firmly believe that if we think of it as storytelling, if we acknowledge the fact that teaching is storytelling, our teaching becomes more effective. And what do I mean by storytelling in the context of teaching? Well, there's a wide spectrum of things that we do when we interact with our students in a course in ways that facilitate their learning. There are, of course, lectures and mini lectures and online lectures and discussions we lead and so on that are obvious opportunities for storytelling, telling the story of how the human body is built and how the human body functions. But when we approach our entire course as an opportunity for storytelling, it gets even better. It's sort of like a filmmaker or an amusement park designer, amusement ride designer, who thinks of it as telling a story. And so there's a beginning, a middle, an end. And if we think of that as a beginning, a middle, and an end, and take those things that we know about teaching and learning, such as learning outcomes that we expect, the place that we're kind of starting from, like what do we want the student to learn, and then how are we going to get there, and then how are we going to wrap it up at the end and conclude and pull all those threads together. We can do that when we're physically telling a story in the classroom, let's say in a lecture context, but we can also do that in the entire course design and the design of each component of that course. If we think of it as a story, then I think that it works better in our own minds, and therefore it translates better for the student. And once the student starts thinking of these as stories, and my students, I use that terminology with them. I'll say, remember when I told you the story of how the nephron works? And they start getting that mindset of these are stories, and that makes it more accessible to them, I think, than when they think of it as the lecture on the nephron. If it's the story about the nephron, wow, suddenly it takes on a whole different flavor than it did before. And it's not just using that terminology in presenting things the same way we've always presented them. I think it's important for us to think of them as a story with a beginning, a middle, and an end, and with protagonists and antagonists and good guys and bad guys and amazing things that happen and so on. And I think that where that starts is to understand that we are walking in the classroom and taking on the persona of a storyteller. So it's a kind of acting. And if you've ever heard professional storytellers or even amateur storytellers, I think you can kind of see the transformation that comes over people, especially if you have a friend or a family member or something that likes to tell stories. Sometimes their affect will change just a little bit, maybe a lot, when they get ready to tell some favorite story of theirs, especially if they're talking to children, but even when they're talking to adults and telling a story to adults. And I think a lot of us as teachers do that. And I think that's a great thing. It's a good thing to have that storytelling persona, that teacher persona that we walk in with, especially for those of us that are introverts. I think that if we think of, walking into a classroom and we're naturally very shy in front of crowds and so on, but we think of it as an acting role that we have and we walk in, then it puts us and our students at much more ease. Because now it's not Kevin, the teacher anymore. It's Kevin, the storyteller. And I'm going to come in and tell you some stories. And I'm an actor for that time that I'm spending with you. So that acting part is important. One aspect of that is that people usually want their storytellers to be living the story with them, sort of as if the storyteller is hearing the story for the first time as well. Most storytellers do not speak in a monotone and just kind of rattle off the events of the story and so on. They get somewhat dramatic. They move their arms a little bit. They move around a little bit. They act out certain parts. They change their voice at certain parts. And I think that if we do that, and not only that, but have fun doing it. I'll never forget And I've mentioned before in this podcast that I used to be a lion tamer in the circus, and I spent a lot of years learning how to do that and going to circuses and watching other animal trainers and other circus performers and so on. And my mentors pointed this out to me, that you always go in and act like you're having fun. And if you act like you're having fun, then everyone around you will have fun. And then pretty soon, even if you weren't, you're now having fun. And psychologists tell us that happens. They often use it as a technique to help people who are having a hard time having fun or having a hard time smiling or being happy, is to, just smile a lot and you'll feel better. And maybe there's some physiological things that go along with that. My point being that if we walk into our classroom and consciously think about the fact that we're taking on a new persona, a persona who's going to have fun, telling a great story. And then the next step is that most people in our classes, or most people who want to hear a story, have curiosity about certain things. And I think that our students have a natural curiosity about the human body. My theory is that everybody who lives in a human body has some level of curiosity about how the body is built and how it works. But I think our students in particular come in with that because they've been drawn to a career path that involves the human body. So they already have that curiosity. So we can start out with, did you ever wonder how the kidney does what it does? What does the kidney do? You got any ideas? And then move from there into, let me tell you about the nephron. The story of the nephron is an amazing story. It's the weirdest things that happen and the most unexpected things that happen. But at the end, we end up reaching our goal of maintaining homeostasis. And so, telling it as a story and having characters in that story, identifying the characters in that story, the different segments of the nephron tubule, for example, could be characters, or the ions and other molecules that are moving, glucose and so on, that are moving back and forth across the wall of the nephron. Those could be characters in our play. We have a lot of recurring characters in our stories, don't we? I often will say that. It's like, here's calcium again. Here's, our recurring character has come back in for another episode of A&P. So, having that story perspective is important. Having beginning, middle, and end is important. I think if we can introduce some conflict and resolution, that'll help. Talking about the nephron, we can talk about how, if a negative ion is pulled across the membrane, what are the positive ions going to do? We're going to have this electrical charge building up. Is that something that we want to continue? Or are we going to allow the positive ions to follow the negative ions, or vice versa? Are we going to pull these ions across and let the water just stay there? Are we going to have an osmotic imbalance? Or are we going to let the water come across too? So we set up conflict, we identify conflict, and then we say, how is that resolved? How do things naturally occur? And a lot of times, the audience of the story, our students, they kind of know how it's going to go. Don't you have that experience when you're listening or watching stories? I know in movies, sometimes I'll feel like I'm getting to know a character and I can predict what they're going to do next, or especially in miniseries and television series and things like that, where you'll start to be able in your own mind predict, how a character is going to react. And I think if we set that up for our students, they can start to do that too. They can sort of tell what's going to happen when there's an electrical imbalance across a membrane, or an osmotic imbalance across a membrane, or any one of a number of other kinds of conflicts that they've seen resolved in other areas of the body. And when they do that, they're just not being good listeners to the story. They're starting to get to those higher levels, or maybe I should say deeper levels of understanding of how the human body works. And so they're just naturally being drawn to higher level thinking skills, to higher level understandings of what we want them to understand. I think another aspect of storytelling that can be very effective is when there's some shock and awe involved. And what I mean by that is like, oh my gosh, how can this happen? how can this happen in the body? How, is this really what we're going to do? If we think about all of the fluid that is filtered out of the glomeruli into the nephron, and we think, oh my gosh, you add all that up, that's gallons and gallons and gallons of water we're going to end up lost from the body. That's shocking. That is awesome. And then we resolve that. We say, well, wait a minute. That's, do we really pee 50 gallons a day? I don't think so. So something's got to happen. What could possibly happen before that fluid gets out of our body that can restore the balance and prevent us from drying out almost instantly? And so, if we are bringing that shock to the fore, if we're dramatizing that, and bringing it out. And not only that, but acting shocked ourselves. Don't good storytellers do that? Don't they act surprised even though they've practiced this story a million times and probably have told it 1,000 times? But they do. They act out. They dramatize that shock. And I do that with my students. Like, oh my gosh, how can we do that? And they know that I'm not being totally sincere. They know that I know the end of the story and what's going to happen. But it helps to tell the story, and it helps them hear the story. I'll never forget a ringmaster announcer in a circus that I saw several times. He's French, and even though I did see him in the United States, I also saw him over in Europe. And he's one of the best ringmasters I ever saw, even though I only understood about half of what he talked about because he usually spoke in French. I mean, he did do a little bit of English, especially when he toured in the United States, but he mostly announced the various circus acts in French. And he was so good. You don't think of the ringmaster as being one of the stars of the show, but he was always one of the stars of the show in whatever circus he appeared in. And the reason is that he became the storyteller. And he would not just announce an act, he would stay around and he would watch. And you could see him act out the shock and the awe when a high wire artist was going across and maybe was teetering a little bit. And you would see him and his face would change. And he would appear to be just as shocked as the rest of us. And he would laugh when there was a comedy circus act on, like maybe Comedy Acrobats or something like that. And he would act out in a very dramatic way. He would act out his reactions. And what that did was get us as the audience more involved in the circus act that we were seeing at that moment. And that's the kind of teacher I want to be. I want to be just like that ringmaster. I want to be expressing that shock and that awe and that amazement of the human body to maintain homeostasis under a wide variety of conditions. And even when bad things happen, can recover from it if things are happening normally. And we can be shocked and saddened when things get broken, when the heart valves don't work right, or when the kidney doesn't maintain homeostasis consistently in terms of our fluid and electrolyte balance. And one last thing that I'll mention, there are many other things about storytelling, but one last thing is to use a lot of pictures, don't use a lot of words. So I think anatomy and physiology, both ends of that, the anatomy part, the physiology part, lend themselves to visual storytelling, where we show a picture and walk our audience, our storytelling audience, through that part of the story. And then we change the scenery and we walk them through that part of the story. Putting up 25 bullet points in one slide is not going to help storytelling. What we should do is use a title, maybe one or two little bullet points, especially if there's subtitles of that story, to help the students understand sort of where we're going in that story. It's sort of like when you go to the theater and you look at the program. What you will see is a very, very short outline. It'll have Act 1, Act 2. It'll list the scenes and tell you some short little thing about each scene. Maybe it just tells you where it occurs, or what major thing happens or could be happening in that scene. If we're going to be using slides or other visual aids, make them mostly pictures and make them be very few words. I think you'll tell a much more effective story. Your students will be listening to your story rather than trying to read the slide and copy it down if we do it that way. So a few storytelling tips for your next A&P class. Have fun with it. The skill of storytelling. Well, this one is not new to regular listeners of this podcast. I first brought this up way back in episode 12. And I often riff on the idea that teaching is a form of storytelling. And that if we think of ourselves as the tellers of the story of human structure and function, all the rest just flows naturally. There are many aspects to telling a story, and one of them is actually making up stories like we do when we use analogies. For example, in episode 15, I related an abbreviated version of the love story I tell involving actin and myosin, with a subplot of the love story between calcium and troponin. So anytime we use an analogy, we're doing storytelling in a very concrete and obvious way. And we use storytelling when we're constructing case studies or mini-case test items, or just giving examples of practical scenarios where knowing some concept of A&P is necessary. But another aspect of storytelling is having students explore concepts in a logical sequence. That is, a sequence that tells a story. An intelligent machine can relate all the facts of a story, even the story of human structure and function. And an intelligent machine can even try to fit them into any of a library of different plot patterns. But I'm not so sure a machine will ever be able to figure out how to tell a compelling story about how urine is formed in the nephron. But I can. And I think that even in the age of AI, coming to higher education in the near future, I can take my renal stories to the bank. This podcast is sponsored by HAPS, the Human Anatomy and Physiology Society, promoting excellence in the teaching of human anatomy and physiology for over 30 years. Go visit HAPS at theapprofessor.org/HAPS. That's HAPS. In the last episode of this podcast, episode 12, I introduced the idea of storytelling as a strategy for teaching and learning. And I want to continue that story now. I'm doing storytelling again. Continue the story. In the last episode, our hero was hanging from a cliff. And in this episode, no, we're not going to go in that direction. But I do want to continue my story of storytelling. And I want to start with the quote that you heard at the beginning of this episode, in which John Dewey stated, "To be playful and serious at the same time is possible, and it defines the ideal mental condition." And I've taken that on as sort of my motto for my storytelling persona that I use in the classroom. In the last episode, I mentioned this idea that, when we walk into the classroom, it might be useful to take on a particular storytelling persona where we maybe are a little more dramatic than we would be in an ordinary conversation, and that we consciously think about the beginning, the middle, and the end of our story, where we want to go with this story. And we bring in characters and even identify recurring characters such as this ion or this kind of cell or that kind of cell or this kind of a membrane protein or membrane structure and that kind of a membrane structure and so on in our stories. The persona that I use when I tell stories most often is a very playful one. And that's part of just kind of my approach to doing a lot of things, including this podcast, if you haven't noticed by now. But it's certainly my approach to teaching, because I think that anyone has a little bit more connection to, a little more engagement with activities that are playful, that engage our playful nature, than those that are overly serious. There's a time and place to be very serious, but I'm not sure that we need to be doing a lot of that in our courses. I think playfulness really has a role. And as John Dewey has pointed out, and I agree with, the playful and serious can coexist together. And maybe that's ideal when you have playfulness and seriousness coexisting together when we're doing things. And one example that kind of pops into my mind of when I'm particularly playful with my students in A&P is when I pull out my box of phosphorylation frogs. And what these are is a box full of these tiny little toys, something you would get like in a kid's meal at fast food or something, although they're probably not rated for children 2 or under or whatever. But they're little plastic frogs, just fit right in your hand, easily in your hand. And they're made of hard plastic. And coming from their base is a spring. And sort of encircling the spring is a suction cup. And if you push the frog down toward the table, let's say you're setting it on a table, you push it down toward the table, you have to compress that spring. So you have to push, push, push. And then the suction cup hits the base. And when it hits the base and you push down hard enough, it sticks. But that spring is pushing against the frog. It's there between the base and the frog, and it's pushing the frog away from the base. And eventually it's going to overcome the resistance of that suction cup, and that frog is going to jump. And that's the whole idea of this little toy. So I distribute those in class, and every student has one in front of them, and I tell them, go ahead and play with it a little bit. Here's how it works. You push it down, and it's all 5 or 6 of them that are pushed down in front of me, and one will pop, then another will pop, and we kind of play around with the idea that some frogs pop faster than other frogs do. And then I say, well, why are we doing this? Well, partly why I'm doing it is to give them a little bit of a brain break so that they can tackle the idea of phosphorylation in a fresher frame of mind, and also in a playful yet serious frame of mind. And I tell them this is like the phosphate group on ATP. In order to get that phosphate group on there, we need to put some energy into it. We need to push it on there. And where does that energy come from? And we have that discussion of where the energy comes from for phosphorylation. And we say, well, that energy is used to push the phosphate onto the ADP, just like we're pushing the frog onto the base. And then what happens to the frog? It pops off right away. And that's what happens with ATP. That third phosphate group pops off right away. And when it does, it releases energy. Just like that frog releases energy, we can see that it's releasing energy because that energy is being used to do the work of making the frog hop. And so at that point, I tell them, come on, keep doing it. Put that frog back together and keep doing it and keep doing it. And I tell them, well, this is what the cell has to do. Mitochondria are business of putting that frog back, and it hops off, and they have to put it back, and it hops off, they have to put it back. They're doing oxidative phosphorylation. They're using an oxygen-consuming process, and what they're doing is phosphorylating the ADPs. And they're going to pop off, and we can use those phosphates to do work in the cell, or even within that mitochondrion, and that's useful work. And we're doing that constantly. It's a constant effort of, pushing the frog back down, and then it hops. Push it down, and then it hops again. And it's a very playful situation, intentionally playful situation. And yet, whenever I recall those phosphorylation frogs, they've been put up for a long time, I can always go back to that when phosphorylation comes up. And it does come up quite a bit in an A&P course, right? Every once in a while, we're back to that whole idea of using ATP as a source of energy. And we can recall those phosphorylation frogs, and they can visualize in their mind's eye this visual and kinesthetic and auditory and process that they went through in playing with those frogs. So that's just an example of playfulness being part of a story, in this case, the story of the phosphorylation frogs. And that brings us to another aspect of storytelling I wanted to talk about in this episode, and that is analogies. That frog, that phosphorylation frog, is an analogy of the process of phosphorylation. And I don't know any A&P teachers out there who do not use analogies somewhat, at least, in their course. So this is nothing new to you, but I do want to stop and think about and analyze that use of analogies in our courses, because there's some things that I think it's important for us to think about. One is, not all students understand analogies, or at least understand them as well as we do. And I think we need to address that issue. One aspect of that is that not everyone has the same cultural experience as we do. Sometimes it's because of age. There are analogies that I have used that I don't know that my students are of an age group where they would remember the story that I'm using as an analogy. Here's an example. When I talk about why it's important to have such complex control of digestive function, that is, function through the digestive tract, especially controlling secretion and motility in the various organs of the alimentary canal, I use the analogy of that episode from I Love Lucy. It goes way back even before I was a kid, and where Lucy and Ethel get a job in the chocolate factory. And there's miscommunication, and the chocolates are coming faster than they can package them, and it gets all crazy, and it's hilarious. And so what I do when I use that analogy is I show them a little clip that shows them that. And most of my students, even the very young students, they'll say, oh, yeah, I've seen that before. I love that. And so maybe I don't need to show it, but it's fun. It breaks things up, gives us a little brain break. And now we can tackle that idea of the neuroendocrine control of the digestive organs, which is pretty serious, but we're being playful about it when we do and say, well, look, this is like Lucy and Ethel, and we need to get the signal ahead to speed up, slow down so that things don't back up and get all crazy and things are not processed efficiently as they move through the digestive tract and are absorbed from the digestive tract. So that is an example of where I needed to be careful to make sure that everyone could picture that scenario, so I showed them the scenario. But there are a lot of analogies where, we talk about, catching a fish with a hook. Well, maybe not everyone has had that experience, or maybe everyone has. So that's what we need to do sometimes, is sort of explain, the idea behind the analogy, and then use the analogy in our course to explain the concept that we're using, the concept that we're trying to teach or have our students learn in the course. Another aspect of analogies and models, which are a form of an analogy, is to explain exactly what they are and what they're not. A lot of students really have a hard time with analogies. And so at the beginning of my A&P 1 course, I always have a brief discussion I tell them, look, in science we use analogies all the time, not just in teaching and learning, but we use them in describing concepts like the sliding filament model, for example. That's a model. It's an analogy, and it explains a concept. And so I tell them that, look, there are these models, and one of the first models I introduce to them, or the first times I use a model in my class, is in explaining homeostasis. And I use at least 3 different models to explain homeostasis. And you know why? Because any one model isn't enough to really tell the whole story of homeostasis, at least not in my mind. I remember being part of a conversation a number of years ago among anatomy and physiology teachers where they were talking about using a model of like a teeter board or a balance. And we're pointing out, well, there's a lot of things about homeostasis that model fails to cover, that fails to address. And they were very concerned about this. And I was very puzzled at their concern because, of course, it's a model. It's never going to explain 100% what's going on. If I have in my hand a model airplane or a model frog, let's go back to that and say, well, this is a model frog. If you've never seen a frog ever in your life, and I showed you that, you would have some idea what a frog is. But it fails in a lot of areas. It doesn't have the texture of a frog. It's not the size of most frogs, although there are some frogs the size of that little toy. Frogs have functioning legs, not springs and suction cups at the bottom, so it fails in that regard. There's a lot of ways in which it fails. But it does give you the idea of a frog, at least to some extent. Same thing with a model airplane sitting on my shelf. You could say, well, that's not right because there's no people inside drinking tiny little drinks with too much ice, and that would be more realistic if you could do that. Well, yeah, it would be more realistic, but it's just a model that sits on my shelf. It's not really the real thing. So there are a lot of concrete thinkers that have difficulty with that sort of aspect. That is the idea of an analogy to begin with. Then secondly, the idea that it's not really going to cover everything. So how can we deal with that? Well, we need to explain ourselves and say, look, this is an analogy. And there are some aspects of this story that I tell or this scenario that I describe or show to you that are just like the concept I'm trying to teach. And here are the ways it's similar. But keep in mind that they're not the same thing. One is just being used to illustrate the other thing. I think there's, always that handful of students that have a variety of challenges in their thinking, and they're going to need us to maybe work with them a little bit outside of class, kind of explaining things a little more carefully, maybe more than once before they start to get the hang of it. But most people, even if they start with a difficulty with analogies, if they know the story, that is, they're culturally aware or experientially aware of the story you're telling and what is really going on there, they can be coached along so that they understand how that story relates to the concept that you're trying to explain to them. So it does take, though, us not just throwing out allergies, throwing out analogies. Don't throw out allergies either. It takes us more than just throwing them out there. It takes us kind of thinking about, is this analogy going to work? Do I need more than one analogy? When I do homeostasis, I use at least 3 different analogies that cover different aspects of how homeostasis works. In a future episode, I'll go through those analogies, and maybe you use some of the same ones that I do. Maybe you have some better ones that you can share with us. My point is that we need to do a little metacognition and think about how we're using analogies, how that is playing to all the many different kinds of individuals we have in our course. But that is a very effective tool for storytelling, using analogies. Playfulness, also very effective. A searchable transcript and captions for the audiogram of this episode are funded by AAA, the American Association of Anatomists, at anatomy.org. Hey, I'm a member. Why don't you join too? I don't think I've ever met an A&P teacher who does not use analogies in teaching their course. And I have one that I think will be very useful to a lot of you, or it might give you an idea for adapting it for your own course and your own teaching persona and approach to helping your students. At the very beginning of the course, when I'm but reviewing the idea of ions and how important they're going to be in our discussion of human anatomy and physiology, I give them this principle, and I tell them that if they remember this, it will take them very far in understanding the stories that I will be telling them in A&P about how the human body works. And it's this: cells. Cells, let's pretend they're conscious, and I'm not so sure they're not conscious, but we'll pretend they're conscious, and I will tell them that cells hate certain ions. They hate calcium ions. Cells hate sodium ions. And how do I know this? Because whenever calcium ions leak into a cell, the cell goes through a lot of effort in the form of calcium pumps to pump it out. And the same thing with sodium. There are sodium pumps, actually sodium-potassium pumps, that pump out the sodium out of the cell. Sodium leaks in, gets pumped right back out again. We can think of them as some kind of nasty little beast. A lot of people are afraid of snakes. Now, I have the opposite view of snakes in general, but a lot of people, I'll ask my students, if a snake came into this classroom, what would you do? And of course, then they're all saying, scream, yell, jump up on the desk, so on, shoot it, cut its head off, and so on. And I said, well, what would you want me to do? Get rid of it. I said, okay, so, I'm the calcium pump. I'm the sodium pump. That's something we don't want in here. So when the snake comes in, I will grab it and I will throw it back out in the hall. And if it squeezes back in under the door, guess what I'm going to do? I'm going to grab it and throw it back out in the hall again. And I'll just keep doing that over and over to make sure that snake does not get to you. And so that's what the cell does with calcium and sodium. Just like most of my students hate snakes, cells hate calcium and sodium, and they pump it out. But wait, you might say, what about the large number of calcium ions that are stored inside of the sarcoplasmic reticulum of muscle fibers? Doesn't that break down the analogy? Well, number one, analogies never work 100% because they're analogies. They're imperfect. But this one actually does work. If we imagine these snakes that are coming into the classroom, but we don't want them in the classroom, I, as the calcium pump, can grab a hold of the snakes and throw them back out into the hallway. And as they come back in, I can throw them out again. But I could alternatively put them into a sack and tie the sack shut. And that'll keep the snakes away, hopefully, for a little while. And what happens if they slither out of the sack? Well, I'm just going to pump them right back in. And if they slither out, I can pump them right back in. So later on in the course, when we get to muscle fibers and how they work, we can be reminded of that analogy and say, well, remember that what the calcium pumps are doing? Remember that this muscle fiber hates to have calcium. So if calcium leaks into the muscle fiber, it gets pumped out. But some of it gets pumped into the sarcoplasmic reticulum. And there is a circumstance under which it will leak out, and then we'll immediately pump it right back in. So during excitation, it's going to leak out because of the voltage change in the membrane. But right away, the calcium pumps are going to pump it right back in, and now we're back at relaxation again. So it still works. And then I ask them, well, what if there's some kittens that wander into our room? Should I throw those out in the hall too? Like, no, keep those in there. I said, what about puppies? And like, no, you don't need to throw them out in the hall. We love puppies. And so I say, are there any ions like a puppy? And usually I have to coax them along a little bit until they go in the right direction. But what about potassium? Whenever potassium is hanging around a cell, what do? We pump it in. It's that same sodium-potassium pump. So I tell them, if I'm playing the role, sometimes I even act this out. If I'm in a room where the door to the hallways, at the front of the room, or in an area that they can all easily see, I'll act it out and pretend to be grabbing a snake and pushing it out. And while I'm facing the hallway, I'll grab a puppy and pull it in. And then grab a snake on the inside and push it out, and then grab a puppy and pull it in. And so I'm pretending to be the sodium-potassium pump. And I then take it a step further, I guess, and tell them that if you just memorize those facts, even though it's kind of crazy, it's kind of silly, it's reinforced by the silliness. Learning research tells us that crazy visual images help us remember things. So they have this crazy visual image of the snakes and the puppies and so on. And that's going to help them as they get further along. And then it's not long before we start talking about membrane potentials. And they just know that, hey, calcium is going to get pushed out. And it even comes up in maybe some unexpected ways later in the course when we're talking about making bone tissue, osteogenesis. And we see that, the cells, the osteoblasts, what are they doing with calcium? Pushing it out. They're getting calcium from the blood and they're pushing it right out. And it's all accumulating on the outside of the cells. The calcium of bone tissue is not in the bone cells. There's very little in the bone cells. If you want to find calcium, you look outside of cells. If you want to find sodium, look outside of cells. There's a lot of sodium outside of cells. Very little sodium inside a cell. Looking for potassium, where do you look? You look inside the cell, because cells love potassium like people love puppies. Distribution of this podcast is sponsored by the Master of Science in Human Anatomy and Physiology instruction, the HAPI degree. Looking to power up your game in teaching A&P? Well, check out this online graduate program at nycc.edu/HAPI. That's HAPI. Or click the link in the show notes or episode page. In a past episode, I talked about how storytelling is important in teaching in general and in teaching human anatomy and physiology in particular. And that led to a discussion about how being playful and serious at the same time really works well. And coming out of that discussion was the idea that playful analogies can be very helpful. And of course, with analogies, they're never really 100% true to the concept that the analogy or the model is trying to represent, but they sometimes help the little gears inside our brain to connect with the reality of the concept. So keeping that all in mind, I want to, as promised in a past episode, share with you one of the analogies, one of the little stories that I tell. And it's kind of playful and fun, but it's also very serious. And I'm going to do that in this episode. So now is the future. We're now in a future episode. How does it feel to be in the future? Before I get into this story, which is a shortened version of the story, we don't have time for a mini series here. It's a version that I put into a little booklet that I created a while back called The Survival Guide for Anatomy and Physiology. It's just a handy little helper for students who are struggling in A&P, and it's got a number of analogies in it, and this is one of them. So keep in mind, it's an abbreviated version of the story I tell. And you can imagine how it can be expanded to include some other details of the concept that I'm going to be getting into in a moment. And the concept is the process of muscle contraction and relaxation. What's happening at the molecular level within the muscle fiber. So I kind of often call it the muscle love story. It's, more or less loosely based on the idea of Romeo and Juliet and other kinds of, old classic love stories. And so it does have some traditional gender roles in it. So be forewarned because of it being built on these old classic love stories. And before I get into it, I just want to mention also that there are previous stories that I've told in my class that get the students ready for this. Particularly, I put a big emphasis on the cytoskeleton when we're discussing the cell early in the course. I know for a long time I just kind of skipped over the cytoskeleton, but I've realized that it's really an important character in many of the stories of the body. And of course, science in general has been realizing that, and we're starting to learn more and more about the cytoskeleton and how the components of the cytoskeleton and how they function really are central to understanding a lot of the basic principles of A&P. So one of the things I do when I'm discussing the cytoskeleton is bring up the idea of motor molecules. And I even mention myosin and kind of look at it just in a very simplified way, how motor molecules work, and tell them that there's going to be this later story where myosin is going to be a major character, and it's going to be interacting with an actin filament, and it's going to be doing this motor molecule thing. And that's how muscles contract. And I'll leave the details of the story till later. Well, now it's later. Here we are, Back to the Future again. That'd be a good name for a movie, wouldn't it? Back to the Future. First thing we have to do is set the scene for the story and introduce the characters. And before I do all that and really start the story, I've already described for my students the typical muscle fiber, and more importantly, the myofilaments and the sarcoplasmic reticulum, or SR, and what it does, and the T-tubules and where they're at and what their characteristics are, and all the important part, their structures and their physical relationships to one another. So they have all that down, and their heads are spinning, and they're trying to figure out what's going on. So now is a good time for a brain break, right? We can sort of step away from that and play for a little bit. And so, I put even more drama into my voice and start moving around a little bit more to tell this story. And so once upon a time in the land of the muscle fiber, several interesting characters live. Myosin is in love with the girl next door. Her name is Actin. The problem is, as it often is in these love stories, the problem is that some of the villagers want to keep myosin and actin apart. Young lovers are never a likely match according to the other people around them, are they? There's a group of women there too. Each of them is called troponin, or troponin if you prefer. And they constantly try to keep myosin from getting to his true love actin by holding up poles made of tropomyosin. These tropomyosin poles could be easily knocked out of the way by the brave and strong myosin, But all those troponin girls are very strong too. And they keep the tropomyosin in its blocking position. Every good love story needs tension like that. Something keeping the lovers apart. In addition, there's a good subplot. Turns out, troponin girls are in love too. They all pine away for their true loves, all of whom are named calcium. The problem for them is worse than for actin and myosin. All of the calciums are under guard in the SR, the sarcoplasmic reticulum. The SR, as it turns out, happens to be a sort of prison yard on the banks of the rivers which travel through the village, and those villagers call them T-tubules. Given their situation, it's very unlikely that any of the troponins will ever be visited by a distant calcium imprisoned in the SR. Poor things. However, one day an odd thing happens, as it always does in these stories. A stranger, of course, it's a stranger. There's always a stranger. A stranger called acetylcholine is sent by the governing nervous system. Acetylcholine, or ACH to his friends, hits the sarcolemma, which is the wall around the village. And that launches a traveling voltage fluctuation. Now, you and I would call it an action potential, but the villagers think of it as a lightning strike. Well, that voltage travels right along the sarcolemma. When it gets to each of the T-tubules, it travels right down the T-tubules and thus crisscrosses the village. As it travels down each T-tubule, the voltage zaps the SR, which sure does startle the guards. The guards are so stunned that they let many of the calciums escape and run all over the village. Oh my. The troponins, of course, can hardly believe it. They dreamt last night that they were surrounded by calciums, and lo, it has happened. The calciums and the troponins embrace. In the heat of passion, they twist around a little bit, and the troponins completely forget about holding up the tropomyosin poles. Well, that gives myosin the chance he and actin have been waiting for. He moves across the barrier, and myosin and actin immediately start, well, getting passionate with each other. Myosin is very excited and just keeps actin moving along. I'd get into sliding filaments here, but it's a family show, okay? You get the picture. We have contraction because actin is being actively pulled along by myosin, who is using a lot of energy. In the meantime, back at the SR, the guards have recovered and now rounding up the calciums and taking them back to the SR where they belong. As each troponin tearfully bids her calcium goodbye, she realizes that she was not paying attention to her job, and so she gets back to it. The next time myosin is ready to cross over to actin, he can't. He's again blocked by those tropomyosin poles. And they're being held in place by the troponins, because they're back on their job, remember? Thus, the little village returns to its relaxed state, if you can call it that. It's just a matter of time until it all happens again. All of the old attractions are still there, and someday acetylcholine, or ACH as his friends call him, will ride into town and stir up another electrical storm. So that's the end of that chapter of the story, but I keep coming back to that story as we start to add layers of information onto that. For example, I always take the opportunity of discussing muscle contraction to bring into the consciousness of my students the idea of metabolism, particularly, how the myosin gets the energy. The myosin, of course, gets energy from ATP, but where does ATP get the energy? Well, the ATP, those are like little batteries. Those are recharged in the mitochondria. And so where is that energy coming from that those ATPs can be recharged? Mostly in the mitochondria, not entirely, but mostly in the mitochondria. Well, ultimately that comes from glucose. And so we can talk about that whole process and bring that into, well, why do we need to know about metabolism? Why do we need to know about ATP? Why do we need to know how glucose breaks down and releases energy and that's transferred to ATP? Why in the world do I need to know about oxidative phosphorylation? I'm only going to be a nurse, as if only is appropriate when talking about any of the health professions. The idea being like, you're trying to teach me too much, but now they can see that, well, it all fits into the story. There's a lot of interaction here. There's drama, and who can't relate to a good dramatic story? So, you might already be using some kind of a story like this. And this might give you some other ideas to maybe change up your story a little bit or add to or take away. You might have a different story. And if so, I'd really love to hear it. And I'm sure our other listeners would. So call into the podcast hotline, which is 1-833-LION-DEN. That's LIONDEN. Or send it to me by email. That's podcast@theapprofessor.org. And I hope you all live happily ever after. The A&P Professor podcast has been entered into the People's Choice Podcast Awards. But I need a lot of nominations from listeners to get this podcast into the final slate of nominees. It only takes a minute or two to nominate, and it must be done by the last day in July. Just go to podcastawards.com and nominate the A&P Professor. That's it. I'm in the education category. You'll also have the opportunity to opt into the pool of judges if that's something that you might be interested in. That's podcastawards.com, or just click the link in the show notes or episode page before the end of July. I really do appreciate your help with this. Regular listeners to this podcast know that I like to look at the process of teaching human anatomy and physiology as a process of storytelling. We are telling the story of how the body works. We're telling stories about how the body is put together. And when I do that with my students, I often use the phrase, last best story. I tell my students, the stories I'm telling you are the last best stories. And what I mean by best stories is the stories that have the most evidence behind them, the ones that are most widely held by those scientists who are experts in that particular area of human science. And of course, it's the best story in terms of my keeping up with the best stories. And that's where the last part comes in. The last best story means, well, what is current? We've had all kinds of stories over the centuries about different parts of the body, how they're structured, how they work. And we've seen that change as new and better information comes along. And that process has not suddenly frozen in modern times. No, that's the way science works, is that we're constantly updating our stories, not only with new data, but sometimes we revisit the old data and reinterpret that older data. So yeah, there are many different ways why we want to revise our stories. And what I'm telling you in this course is the last best story. But my students, it's up to you to keep up with those stories, because this is only the last best story. That's the best story 20 years from now is likely to be at least a little bit different. So I'm bringing that up as sort of the framework for mentioning two stories that are kind of in flux right now. One of those stories has to do with adult neurogenesis in the brain. That is, the production of new neurons after birth in humans. And in the 21st century here, this has become a big debate. Just within the last few months, it's become a big debate because within the last year, two big papers came out that seem to be in opposition to one another. One saying that there is firm evidence of ongoing neurogenesis in the adult human hippocampus. And the other one sort of came to the opposite conclusion. And, there's a bunch of things that kind of make this harder to figure out than maybe at first glance you think there should be. And one of those things is that, usually we compare mammals as sort of as if they're one thing. And in many ways, we all are one group of organisms as mammals. And we look at rodents a lot, right? I mean, rats and mice, we use a lot as models for mammalian biology, and more specifically in our case, human biology. And in rodents, you can see adult neurogenesis pretty easily. But in humans, not so much. So that's where it gets a little bit iffy and tricky. In getting to the last best story, a third paper has come out. It's an article in a journal called Trends in Neurosciences. And a neurogenesis researcher by the name of Jason Snyder, he tries to make some sense of what's going on here. And I think he does a good job in helping us clarify what the last best story in terms of neurogenesis in humans is, at least in terms of when it happens in humans. And he points out that the evidence we have so far says that human neurogenesis peaks much earlier in our lifespan in terms relative to when we're born than it would for rats and mice and other rodents, and even compared to some of the other primates. And so even though it peaks before we're born, it does continue after birth, and it gets lower and lower and lower and lower as we go further and further down the lifespan. But even a little bit of neurogenesis after birth adds up over time. So even though it seems like a tiny amount today, and then tomorrow, whatever we have going on is a tiny amount, it does add up. And so it's a little more significant, even though it's a small amount, it's more significant than it first appears. But he also points out that when a mouse pup or rat pup is born, they're at a much different stage of development, generally, but also in terms of their nervous system development, than we are as humans when we're born. In other words, we're a little bit further along that line than rats are. When we look at mice and rats, after birth, they're going to have quite a bit of neurogenesis going on. And so that's why it's so easy to see. When we look at humans, it's harder to find because we're not doing very much of it. And so the other thing that he points out is that while we're working out exactly how much is going on when after birth in humans, and it does seem like there is some small amount of that, but even if there's not, it's still useful to look at when it is happening, before birth and perhaps just after birth, because those neurons that are showing up later in the stages of development, they're probably more capable of plasticity that is important to forming new memories and doing things like that, which is, of course, important and essential in human brain function. So, you want to hear the last best story? Go to the link in the show notes or at the episode page and look at that paper from Jason Snyder, and that might help you figure out what the last best story is. Not that you want to go into all that detail in your A&P course, but throwing out these ideas that, scientists are looking at this right now. Scientists are looking at that right now. That helps our students understand the nature of science. That the story that they're learning in your course is a great story and a useful story, but get ready for it to change. Here's our basic information that you ought to know now, that everybody knows now, but get ready for it to change because that's the nature of science. The other story I just want to mention briefly is one that came out, probably a good year and a half or 2 years ago. It was published in Science from a very respected lab, where they came out and said in the autonomic nervous system, we normally distinguish between, a sympathetic division and a parasympathetic division. And when we look at anatomically where these pathways are located, we see that they are connected, with the central nervous system in the thoracolumbar region, which would be the sympathetic pathways. And then the parasympathetic pathways, they're coming from the cranial and sacral regions. And that has been sort of a classic way of looking at autonomic structure and function for quite some time. That's what's in all our textbooks, right? And has been for a long time. And what this lab came out with is the idea that, well, maybe that's not really the way we always thought it was, that, maybe we're kind of stuck in a rut there. And by doing some studies in terms of the gene expression during the embryological development of these pathways, they made a case that really a better way to look at the autonomic nervous system would be to simply divide it into cranial and spinal. And that all of the spinal pathways we should call sympathetic. And all of the cranial pathways then are parasympathetic. So that begs the question, what about those sacral pathways, those pathways that originate in the sacral segments? And this group said, well, we're going to call those sympathetic because they are. When you look at gene expression, when you look at embryological development and so on, they belong with the other spinal pathways. And so this is a way to simplify our understanding of the autonomic nervous system. Well, almost immediately, there was a lot of pushback on that and saying, wait a minute. What about the neurotransmitters that are being used? And the original paper's author said, well, yeah, but we've always known that there have been exceptions to those rules about the pharmacology, that is the neurotransmitters and neurotransmitter receptors that are used along those pathways. And so therefore that really shouldn't be a question. So, they've been kind of going back and forth about that. And it does look like we're, the people that really do the science here, that really research in this area, are still sticking with the classic model. But I think what's important to know, and what I mentioned in my classes, is that there is this idea out there that maybe things aren't that way, that maybe there's a better way or a different way of looking at it. And that may help simplify things. It might make them worse. And so if you want to look at the two sides of that debate, and I also have a link to a more recent article that just came out not long ago that kind of looks at both sides and looks at the pros and cons of both sides of that argument. And you can take a look at that and really dive as deep as you want into the details of how that argument is going. But I think it's an argument that we ought to be aware of as A&P teachers, because it might influence how that story is told as we go forward. But I think more importantly, it gives us a better sense for the kinds of things that happen in human sciences, so that when we're telling our stories in class, we can be portraying or telling the stories in a way that is informed by that process, and that really, makes allowances for those changes that can and do occur in the way we tell our stories. So there you go. That's my last best story for this episode. Well, I hope this episode has triggered some creative thoughts for seeing your role of teacher as that of a storyteller, relating the amazing and ever-changing story of the structure and function of the human body. This was a special episode featuring related clips from the podcast archive. Our regular lineup of new preview episodes and full episodes will resume again in a few weeks. And hey, don't forget that I always put links in the show notes and at the episode page at theapprofessor.org in case you want to further explore any ideas mentioned in this podcast, or if you want to visit our sponsors, which I'd love to see you do. There are many ways to stay connected to this podcast and get new episodes as soon as they're released. Just go to the approfessor.org/listen to explore the many ways you can do that. And I want to remind you that if you phone in or send a recording of your suggestion for the A&P Professor Book Club, I'll send you a $25 Amazon gift certificate. And if you're among the first 5 contributors in this promotion, you'll be put into a drawing for a free Amazon Kindle Fire HD10 tablet. Or you're welcome to call in with your questions, comments, and ideas to the podcast hotline. That's 1-833-LION-DEN or 1-833-546-6336. Or send a recording or a written message to podcast@theapprofessor.org. You can always follow this podcast on Twitter, Facebook, or Instagram using the handle @theapprofessor. I'll see you down the road.
The A&P Professor is hosted by Kevin Patton, professor, blogger, and textbook author in human anatomy and physiology.
Please put this episode on a flat, firm surface. Light the fuse, then step back quickly.